Okay, so we just talked about the electron configuration of atoms. Now we're going to introduce something called ions. So before we talk about the electron configuration of ions, let's define what an ion is. So an ion is an atom that has gained or lost electrons to be like its nearest noble gas. And I guess to be like its nearest noble gas, I'm going to say to have what's called a full octet. Or you could even say a full outer shell. It's just one T. Okay, so an ion is an atom that has gained or lost electrons to be like its nearest noble gas, and the noble gases have a full octet. So if we were to look at, or a full outer shell of electrons. So if we were to look at this, we're going to talk about this a lot more in chapter 4 when we talk about bonding, because bonding has to do with the number of electrons in the outermost shell. But based on, so I'm going to show you this. This is from chapter 4, and again, we'll spend a lot more time on this in chapter 4. This is 4-5. These are called Lewis dot structures. It's on page 146 of my book. But what it does is it shows a dot for each electron. And these are only the electrons in the outermost shell. These are called valence electrons. We're going to cover all of this next chapter. But what I want you to see, this whole middle part here of the transition metals is cut out because they have a lot of special exceptions. But you'll see everything in group 1 has 1 valence electron. Everything in group 2 has 2 valence electrons. These aren't total electrons, these are just electrons in the outermost shell. Everything in group 3, which is the group right here after the transition metals, has 3 valence electrons, 4 valence, 5, 6, 7, 8, except for helium, which has a duet instead of these 8, which are called octets. So everything over here, these noble gases, these have a full outermost shell of electrons. So for helium, that's 2. That's a full outer shell. For everything else, it's 8. So what ions do is they gain or lose electrons to be like these that have the full outer shell, because that's the most stable. And that's what all of this chemistry is about, is trying to achieve a greater stability. So these ions will gain or lose electrons to be like the nearest noble gases. So we're going to go through all of this, but I just want to show you an example right here. Let's look at fluorine. Fluorine has 7 valence electrons. For fluorine to be like neon, it's going to want to gain 1 electron. So remember, electrons are negative. So if the fluorine atom gains 1 negative electron, it becomes F minus, the fluoride ion. Let's look here, a sodium. It has 1 valence electron, but remember, this is just the outermost shell. Once we lose this electron, we lose a whole shell, and we would go back to having 8 in the valence electron in the outermost shell here. So sodium having 1 valence electron, it wants to lose 1 so then it can have 8 in the previous shell. So sodium atom wants to lose 1 electron, which is negatively charged, which means the sodium ion would have a positive charge. So that's the basis behind all of this. I'm going to write all of that out, but just wanted to show you that on the periodic table at the same time. Okay, so ions are charged. They are charged because they have gained or lost something that is charged. So instead of like an atom, atoms are charge neutral, meaning the number of protons equals the number of electrons. Ions are charged. The number of protons does not equal the number of electrons because the electrons have been gained or lost. We're never gaining or losing protons because remember, protons give that element its identity. We can't gain or lose protons. We can gain or lose electrons. Okay, so there's two types of ions. There's a positively charged ion. So a positively charged ion is something that would have lost an electron because it's lost something that's negatively charged. If you lose something that's negatively charged, that makes you more positive. Positively charged ions are called cations. Cations. One way that you can remember this is that they are positively charged. So you can think of like pause, like cat, and it's a cation. Positively charged cations. The other type of ions, so there's positively charged ions, and then there are negatively charged ions. Negatively charged ions gain an electron. And it doesn't have to just be one electron. It could be more than one, but let's just stick to that for now. Negatively charged ions are called anions. So we have cations and anions. I don't have a way to remember anions being negative. So let's just look at the example that I just showed you with the periodic table. Let's look at sodium and let's look at fluorine. Okay, let's look at sodium first. So the sodium, let's look at the sodium atom first and compare it to the sodium ion. Okay, so the sodium atom, it's right here. It has 11, it's number 11 on the periodic table, which means it has 11 protons. So the sodium atom, how many protons does it have? How many electrons does it have? We don't care about the neutrons for this because they're neutral. So the sodium atom, this is number 11 on the periodic table, which means it has 11 protons and 11 electrons because it's charge neutral. Let's also just write the electron configuration real quick for sodium. It's number 11, and I see it's going to go to the 3s block. So I'm going to write 1s2, 2s2, 2p6, 3s1. That is the electron configuration for the sodium atom. 1s2, 2s2, 2p6, 3s1. Here it is, sodium. Whoops. Sodium. Okay, so now let's look at the sodium ion. So the sodium ion is still number 11 on the periodic table for sodium. Let's see how many protons there are, how many electrons there are, and then we'll write the electron configuration. So the number of protons never changes. It still has 11 protons because it can't be sodium if it's not 11 protons. It doesn't matter if it's the atom or the ion. So remember, it wants to gain or lose electrons to be like its nearest noble gas. And by nearest noble gas, I mean the nearest number, not the same row. So the nearest noble gas to sodium would be neon, which is just losing one electron, versus argon, which would be gaining 7 electrons. That's not going to happen. So sodium wants to be like neon, which means it wants to lose 1 electron. So if it loses 1 electron, now it has 10 electrons. So the sodium ion, the symbol for it, if you have 10 negatives and 11 positives, the symbol for the sodium ion is Na+1 because it has a charge of +1. You don't need to put the 1 there. 1 is always implied. If it's more than 1, 2, 3, 4, or whatever, then you would put the number there. So this is sodium +1. So now let's write the electron configuration. It only has 10 electrons because it's going to have the same electron configuration as neon. It has the same electron configuration because it's lost 1 electron. These are called being isoelectronic, meaning it has the same number of electrons. The sodium ion, after it loses an electron, has the same electron configuration as neon. That's called isoelectronic. So I'm going to write 1s2, 2s2, 2p6, and that's it. So this has a full outer shell. So I'm going to go one step further just to kind of illustrate all of this. I'm going to draw, if there was a planetary model, which we know this is not the best way to represent electrons, but just to show you. So let's say here's the nucleus, which the protons and electrons are in, and then here's the first shell, here's the second shell. Okay, so the first shell always has 2 electrons in it. So now 1, 2 electrons. I need one more shell here. So this is the sodium atom. 1, 2 electrons, 3, 4, 5, 6, 7, 8, 9, 10. And then the sodium atom has 1 more electron out here. So it does not have a full outermost shell. It only has 1 electron in its outermost shell. So what this sodium atom is doing to become like the sodium ion is it's losing this 1 electron, then it gets rid of this whole shell. So here's the sodium atom. Now let's look at the sodium ion. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the sodium ion. It's lost 1 electron. When it lost that electron, it lost the whole outer shell. Now it has a lower energy level, but it is more stable because the most stable electron configuration is to have a full outer shell. So this again is called isoelectronic. So the ion will have an electron configuration that is isoelectronic to its nearest noble gas. So this is kind of a crash course in ions. We're going to talk about ions a lot more in chapter 4 when we talk about ionic bonding, but this is how we deal with ions. So now let's do the same thing with an anion. So again, this sodium ion, remember, because it's positively charged, that would make this a cation. So now let's look at an anion. So the one that I said before was fluorine. So let's look at the fluorine atom, the number of protons, the number of electrons, and then we'll draw the electron configuration. Fluorine on the periodic table is number 9. Oh, it's 9 on the periodic table. So that means it also has 9 electrons because it's neutral. So let's write the electron configuration. 1s2, 2s2, 2p5. So these are the 9 electrons. So remember, all of these superscripts, these exponent looking things, would add up to the number of total electrons. 2 plus 2 is 4 plus 5 is 9. So these are where the 9 electrons are for the fluorine atom. So now let's look at the fluoride ion. So it's still number 9 on the periodic table. So the number of protons don't change. I still have 9, but now remember, fluoride still wants to be like its nearest noble gas, which is neon. To get like neon, instead of having 9 electrons, it's going to need to gain 1. It's going to have 10. So it gained an electron. So now the electron configuration, 1s2, 2s2, 2p6, it's gained an electron, which makes the symbol for the fluoride ion F minus, because it's gained something that is negative. I'll go ahead and draw these out again too. So for here, for fluorine, so remember here's my nucleus, 1 shell, 2 shells, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be fluorine. And now it's going to gain an electron. So this is 1 away from having a full octet. So it wants to gain that 1 electron to have a full octet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that makes this F minus. This is an anion because it's negatively charged. The sodium ion is a cation because it's positively charged. Again, these are isoelectronic. So in this example, sodium, neon, which we didn't show, and the sodium ion, neon, and the fluoride ion are all isoelectronic. They all have the same electron configuration because they have gained or lost electrons to be like the most near noble gas, which has the most stable electron configuration. So whenever you're determining if you have, when you're asked about electron configurations of ions, you see what's happened if it's gained or lost electrons, and then you would take that into consideration when you're writing either the electron configuration or the orbital diagram.